Pendulum next. This is the first. I realized in the spring one I skipped over this one where we actually solved this. If you solve it, it was boring. That's why I didn't really explain much. But you basically get oscillation like this and constant weight like that. So it's not really that big of a deal that you missed that. Anyway, we finally get to the pendulum. Now, inverted pendulum, why did I choose the 15 one? Because in control, this ODE is actually valid and the one that you would use to, because your control box over here will control this to go this way. And then if it goes over here, it'll go that way, making it basically 15 degrees at max or something. The only time it does, and then that's why this second one is useless usually and the le less valuable, even though it shows more. It shows from 0 to 360, but and then it shows basically a crash. This over here, I stopped it at pi divided by 2. So basically, this whole thing crashes at pi divided by 2, basically. But the why is not valuable is that this here is the most hard information. Over here is basically mostly gravity. This thing is almost like all the, if you look at the sign, it's basically free fall. Like imagine throwing a ball down and just letting it go. It pretty much is that basically, which is why this is not useful because you can basically model. You see how it's linear or something? This looks basically like a kinetic problem where the mass is dropped. Anyway, the reason I did all these questions because we need more negative coefficient. You realize that the mass over here and the pendulum over here, it's all positive coefficient, and if you move all the things to one side, positive, right? And then you can't really change that. The only way I can change that because I need an unstable system that explodes, and that explosion is very hard to come by in traditional mechanics. So we had to bring this up, and then the other thing I have is a active dampener that I think I will do later, but not right now. We'll